This video is going to go over unit vectors and linear combination form. So we're going to start with unit vectors. What is a unit vector? I want you to think for a moment just what you think it could be. Maybe like where else have you seen the word unit used? What comes to my mind is measurements, measuring my room with feet. Feet is a unit of measurement. So like 1 foot would be that unit measurement, or 1 inch, 1 yard. Also comes to mind is the unit circle, a circle with a radius of 1. And so the definition of a unit vector is a vector with a magnitude of 1. The number. All vectors have a corresponding unit vector. That it's a unit vector that points in the same direction. So it's like if you're flying a kite, the wind is keeping it up at a certain direction, that certain angle, and then you're going to reel it in until it's 1 foot away. It's still going to have that same angle because of the wind, but you're just changing the distance. In the case of a unit vector, we're changing it to have a magnitude of 1. So, for example, we have the vector 0, 3. We have this vector right here. The magnitude of this vector is going to be 3. So if I wanted a vector in the same direction, I have to be along the x-axis, pointing in the positive direction, but only have a magnitude of 1, this one is one of the easier ones. It's just the vector 0, 1, or sorry, 1, 0. So that vector right there, 1, 0, we got that from vector 3, 0. It's pointing in the same direction, and the magnitude of this one is 1, the unit vector. So how could you find the unit vector for any vector? Based on what we saw, what you see in this problem right here, what would you do to find the unit vector for the vectors -2, 5? I'll get rid of those two. So just think about that for a little bit. If you want, you can pause the video and just think about how did we find the unit vector for the other one? How are you going to find the unit vector for this one? So what we did in the last problem, the vector 3, 0 had a magnitude of 3. We want it to have a magnitude of 1. So if you divide the vector by 3, divide both, and then distribute that and divide both terms, you end up with the vector 1, 0. I'll show that to you real quick. You had the vector 3, 0. The magnitude was 3. So if you divide everything by 3 or multiply by the reciprocal, you multiply the 1/3 in. 1/3 times 3 is 1. 1/3 times 0 is 0. And that's your unit vector. So if we do the same thing for the vector -2, 5, we need to first calculate the magnitude. The magnitude of this is going to be -2 squared plus 5 squared. That's going to be equal the square root of 4 plus 25. So the square root of 29 is the magnitude. So if we multiply the vector -2, 5 by 1 over square root of 29, we'll get our unit vector. Now I'm going to show that to you visually using GeoGebra. What I'm going to do is I'm going to select this right here and change the properties of it. Right now it has the vector going from point A to point D. Now, if I just divide each of those points by the square root of 29, and then divide this one by the square root of 29, we get this resulting vector. And if we draw another vector, the original vector back on here, draw the vector, you can see it's on that same line as our original vector. So it's in the same direction. We should, however, prove that it's a magnitude of 1. So let's go back and do that. So I'm just going to clear this off. We have -2 over the square root of 29, then 5 over the square root of 29. Find the magnitude of that. It's the square root of -2 over the square root of 29 squared plus 5 over the square root of 29 squared. So -2 squared is going to be 4. Square root of 29 squared is going to be 29. Plus 5 squared is 25. Square root of 29 squared is 29. Both have the same denominator. 4 plus 25 is 29 over 29. 29 over 29 is just 1. Square root of 1 is 1. The magnitude is 1. So whenever you're trying to find the unit vector, you find the magnitude and just divide your vector by that magnitude. And it will scale your vector to be have a magnitude of 1, which will be your unit vector in the direction of your original vector. So now that you know how to find a vector of magnitude 1 in the direction of any given vector, you can find the vector of any length, just as long as you're given the direction. You can think for a little bit about how. So if I have a vector of any length, I can scale that down to be a vector of 1 in the same direction. And then I can multiply that by any number and have a vector of any magnitude I want. So the original vector, -2, 5, had the magnitude of the square root of 29. By scaling it back to, so now this is the unit vector in that direction. So if I multiply that by 8, we'll have a vector in the original direction of -2, of the vector -2, 5, but that now has a magnitude of 8. So you can really find a vector of any magnitude by finding the unit vector and then scaling it by however long you want it to be. So now we are going to go over linear combination form. This is just another way to represent vectors in a way of writing. What you already learned was component form. And so that's in the form of, like the vector we just worked with, -2, 5. So this is component form. So first, we're going to talk about the standard unit vectors. Standard unit vectors are unit vectors. The two standard unit vectors are 1, 0, and 0, 1. So this first one, this is equivalent to I. Not to be confused with the square root of 1i. In your textbook, they normally bold this to show it's a little different. I just can't bold it very well. And this I represents the horizontal movement of a vector. So, because if you draw it out, that's going to be the vector just going right there. The vector 0, 1 is equivalent to j. That's your vertical movement, that vertical component of a vector, which would just be the vector going up to 1 right there. All vectors have a horizontal and vertical component. If we look back at our vector -2, 5, our first part -2, that's our horizontal component. We're going -2 horizontally, and then we're going +5 vertically. And so I'm going to go over how to convert component form and linear combination form. So I'm going to clear this off. And so let's work with our vector -2, 5 again. So our vector is -2, 5. I can split this vector into two different parts by saying that this is the vector -2, 0 plus the vector 0, 5. When you do that, you can then factor out your terms here. So here I'm going to factor out the -2. So -2, be left with a 1 and a 0, plus factor out a 5 here, left with a 0, 1. So now remember, I was equivalent to the vector 1, 0, and j is equivalent to the vector 0, 1. So we can just substitute the I and j in here for the vectors here. So we'll be left with negative 2 I plus 5 j. And this is the linear combination form of the vector negative 2, 5. And you don't have to go through all these steps to get there. You can just jump straight here. Just negative 2i, 5j. So if I gave you the vector, let's make that u. The vector, say 3, negative 8, that would be equivalent to 3i, because you have, that is your horizontal component, and then minus 8 is your vertical component, so it's attached to the j. And that would be the linear combination form of the vector 3, negative 8. And you can use either one for different operations that you use, but it is important that you know how this works. To show you a little bit about what you can do with this is some vector operations. You should have already learned how to do those, add and multiply vectors together. So let's say we have the two vectors u equals negative 3i plus 8j, and v equals 2i minus j. Find 2u minus 3v. So 2u minus 3v is going to be equivalent to 2u, so we're going to plug in u here, negative 3i plus 8j minus 3v, plug in v, 2i minus j. So now we just distribute the multiplication in. Negative 6i plus 16j. So negative 3 times 2 is minus 6i plus 3j. And now we're going to combine like terms. Combine our i's and combine our j's. So it's going to be a negative 12i plus 19j. And that's your answer. If you want to, you can then convert it to component form if you want. That would just be negative 12, 19. So your vector operations can be done in whichever way you want, whether you want it in linear combination form, like here, or in component form that you already learned. Both ways work and will result in the same answer. Thank you for watching.